In 1901, off the rocky coast of the Greek island Antikythera, a group of sponge divers made the discovery of a lifetime. They found the wreck of an ancient Roman cargo ship lost to the sea for 2 millennia. Among the scattered marble statues and pottery, they recovered a lump of corroded bronze so deformed it was initially mistaken for a rock. It sat in the National Archaeological Museum in Athens for decades, dismissed as a curiosity. It wasn't until the 1970s, with the advent of X-ray and gamma-ray imaging, that humanity realized what it had found. Inside that corroded lump was a machine of shocking complexity. A system of over 30 intricate differential bronze gears capable of tracking the movements of the sun, the moon, the 5 known planets, and predicting eclipses years in advance. It was an analog computer. To be clear, nothing even close to this level of engineering would appear on this planet for 1,400 years with the astronomical clocks of medieval Europe. This device should not exist. It was the pinnacle of a brilliant lost world, a world of Hellenistic science that vanished. The knowledge was so fragile, it was lost in a single shipwreck. But what if that ship never sank? What if this one machine and the entire school of thought that built it had survived? What if the Romans, masters of engineering, had gotten their hands on it? It wouldn't have just changed the ancient world. It would have prevented our world from ever being born. First, we have to understand what this was. The Antikythera Mechanism wasn't a one-off invention by a lone genius. It was the end product of a whole school of thought. This was the world of Archimedes, of Hipparchus, a world where theoretical science and mechanical engineering were one and the same. They weren't just thinking about geometry, they were building machines based on it. This school of thought understood how to use complex interlocking gears to model the very heavens. It was a philosophy of automation. In our timeline, this knowledge died out. The ship carrying the mechanism, likely to a wealthy Roman patron, sank around 100 BC. Rome itself was a practical power. They were brilliant at roads, aqueducts, and concrete, but they valued civil engineering over the complex theoretical science of the Greeks they had conquered. The knowledge fragmented, the school of thought dissolved. The fragility of this wisdom, passed down from master to apprentice, meant that one storm, one lost ship, was all it took to set humanity back over 1,000 years. But in our alternate timeline, the winds are fair. The ship, with its priceless cargo of Greek technology, and perhaps even the engineers who knew its secrets, arrives safely in Rome. The divergence point is not a battle, it's an unboxing. A Roman senator, or perhaps the engineer Vitruvius himself, examines the device. He might not understand the complex astronomy, but he understands gears. And as we prepare to unbox this alternate history, if you enjoy exploring these hidden turning points in reimagining our past, take a second to hit that subscribe button. We explore questions like this every week, and we'd love to have you on the journey. The Romans are, above all, masters, copiers, and adapters. They see this intricate machine, and immediately, the school of thought is saved from extinction. They don't just put it on a shelf, they take it apart. They replicate it. The immediate impact is military and logistical. Roman odometers, which in our timeline were simple devices, become hyper-accurate using Antikythera-style gears. Their ballista and siege engines, already fearsome, are now fitted with complex gearing for rapid reloading and precise targeting. Roman legions can map their conquests with unprecedented accuracy. Their grain shipments are tracked. Their building projects, powered by more efficient geared cranes, rise faster. The empire becomes more efficient, more lethal. But this is just the prelude. The real spark happens about 150 years later in the city of Alexandria. In our timeline, around 50 AD, a brilliant inventor named Hero of Alexandria described the aeolipile. It was a simple, hollow sphere that spun wildly when heated. the world's first, most basic steam engine. But in our timeline, it was seen as a toy, a temple curiosity. Why? Because no one knew what to do with it. They had no way to translate that spinning motion into useful work. They were missing the mechanical bridge. In our alternate timeline, Hero of Alexandria is not just a theorist. He is the heir to the Antikythera school of thought. He doesn't just see a spinning toy, he sees a power source. He combines his steam theory with the intricate gearing of the Antikythera. The result is the invention that defined our own industrial revolution, the steam-powered piston, a machine that can push and pull with the force of 100 horses. And what is the first thing this new Roman Hellenistic science builds? The same thing our own revolution built, a pump, a steam-powered water pump. This single invention changes everything. In our timeline, Roman mines for iron, silver, and gold were constantly flooding. They were limited by how deep they could dig. In this new timeline, steam pumps, fueled by wood and eventually coal, pull the water from the earth. Roman mines can now go hundreds of feet deeper. The empire is suddenly flooded with a near limitless supply of metal. But it doesn't stop there. More coal and more iron means more steam engines. This new unlimited power source begins to replace muscle. Instead of donkeys, massive steam-powered mills grind the empire's grain. In the fabricae, the Roman state factories, steam-powered hammers forge swords and armor. Automated, geared looms, ancestors of the power loom, churn out textiles for legions and citizens. Rome is undergoing an industrial revolution, and with it comes a revolution in transport. They already have the roads. Now they lay iron rails on top of them. Steam-powered wagons, primitive locomotives begin to haul ore from the mines to the cities and legions from the frontiers at speeds that would seem godlike. By 300 AD, the Roman Empire is unrecognizable. It is not the crumbling, overstretched state of our history. It is an industrial colossus. So what happens when this Rome faces the challenges that destroyed it in our world? The crisis of the 3rd century? It still happens. But an empire with rail logistics and industrial-scale manufacturing can respond to usurpations and invasions with overwhelming speed and force. The barbarian invasions? How does a horde of Goths on horseback fare against a legion supported by steam-powered artillery? How does Attila the Hun threaten an empire that can move 30,000 men by rail in a single week? The Battle of Adrianople, the sack of Rome in 410, the final deposition of the last emperor in 476, none of it happens. The Western Roman Empire does not fall. It dominates. The Dark Ages are completely averted. There is no medieval period. There is no Renaissance because the classical knowledge was never lost. This industrialized Rome would crush the Sassanid Empire in Persia. It would push deep into Germania and Scythia. Its steam-powered ships, armed with advanced ballistas, would explore the globe. They might reach the Americas. They would certainly clash with the empires of China. History as we know it is gone. But would this world be better? Imagine a Roman steampunk world, a world of staggering technological advancement, but ruled by the brutal, totalitarian logic of an emperor. A world where slavery wasn't abolished, but industrialized, where legions armed with advanced weaponry enforce imperial will across the globe. A world without the 2,000 years of philosophy, social change, and struggles for rights that shaped us. This is just our interpretation of how things could have gone. What do you think? Would this Roman superstate have eventually collapsed under its own weight? Or would we be living in a global Pax Romana right now? Let us know your theories in the comments below. We look back at the Antikythera Mechanism as a beautiful, tragic what-if, a glimpse of a future that was almost ours. But perhaps its loss was a blessing in disguise.
Perhaps humanity needed to lose that knowledge, to endure the Dark Ages, to find its way back to science on its own terms. History is not a straight line. It is a fragile, branching path. And sometimes, the entire fate of the world can depend on a single, doomed ship sinking silently into the depths.